Hi everyone, we have a problem in front of us and I wanted to show you how to approach that. If you see a fraction, as we discussed before, if you see a fraction, you have two fractions, 1 and 2. If you see a fraction, then try to get a common denominator, combine that into one fraction instead of two. Instead of two terms, we want it to be one term. So let's see how we can do that. Well, this side has sine t minus 1 and the other side has sine t plus 1. Those two are conjugates of each other. It just happens to be like that. But to get a common denominator, you want to multiply this side right there by sine t plus 1. It's hard to write. Oh, even harder than the other cream that I was using. Alright, let's see what we can do. Okay, and the other side multiplied by sine t minus 1. Similarly, we're gonna do the same thing we did in the bottom on the top. So that whole thing will also be multiplied to the top. And that whole thing right there will also be multiplied to the top. So now if we look at our denominator, it's going to have, sine t plus 1 times sine t minus 1. That's the denominator for both. The numerator for the first one is sine t plus 1. That's the first one right there. And the second one has a sine t minus 1, and that's the plus sign from the equation right there. So the common denominator allowed us to combine the top, which is huge, because if you notice, we have a plus 1 and a minus 1 that can cancel, because that plus sign really, if it was a minus, you would have to distribute that minus to the parentheses, but because it's a plus sign, we just put it and added that second term right there. So a plus and a minus would go away, and then that would equal something. 2 sine t. Sine t plus sine t is 2 sine t. Some people confuse that with sine t or sine squared t. If we're multiplying, yes, we square things and cube things, but we're not multiplying, we're adding. So like x plus x is 2x, t plus t is 2t. Same thing, sine t plus sine t is 2 sine t. So let's look at our denominator. We have two conjugates multiplied. So now we need to review what happens when we FOIL two conjugates or multiply them together. When we multiply two conjugates, a plus b times a minus b, or sine t plus 1, sine t minus 1. So means the first term in both cases is the same. So a and a, like sine t and sine t. The second term is also the same, so we have b and b, and 1 and 1. And then the only thing that's different is the middle sign. So we have the middle sign, here is a plus, the middle sign here is a minus. So when that happens, when you multiply two conjugates, the result is just as if you're multiplying a times a is a squared, positive b times negative b is negative b squared. So that's always going to happen. It's just the first term squared minus the second term squared. Well, why that happens? Because if you FOIL, a times a is a squared, and then you'll have the last term is b times b, well, it's negative b squared. But then the middle terms, you'll have positive ab for those inside terms, and then negative ab for those outside terms. So when we FOIL, we do outsides and insides. So in that case, we have positive AB, negative AB. Those would cancel each other, and that's why we're left with only a squared minus b squared. So the middle term, which we do by, we get by FOILing the outsides and the insides, would actually cancel, so that won't exist. So what do you think is the denominator for that guy on top using that rule? Yes, sine squared t minus 1 squared, and well, 1 squared is just 1, so I can put the square, or I can just say 1 squared is 1. So, well, why is it not sine t squared? Well, if I write sine t squared as sine t all squared, then that's fine, because those two are equal to each other. Sine t all squared and sine squared t, those two are equal to each other. It's the same thing. We don't want to write the parentheses all the time, so that's why we put the square right here. But here's what not to do. What not to do is to put the square on top of the angle which is t. That's totally wrong, and you don't square the angle. You don't want to do that. The angle is not squared. What's squared is sine t altogether. It's the function. So don't do that when you're solving. Well, let's take it one step further. What do we have? Let's see. If we recall our identity sine squared t plus, well, sine squared x plus cosine squared x is 1. Well, t, x, theta, they're all angles. It doesn't matter. So the input for a function is an angle. So sine squared plus cosine squared is 1. We know that. We know that identity, we call it the mother identity in class, if you remember, and we know that by heart. So, well, how is this related to that? Well, when you see sine squared, cosine squared, or something like that, it's normally just related to that identity somehow. So, well, how did that turn into this? Okay, well, if we subtract 1 from both sides, that would be a 0, and that minus 1 would be somewhere here. And then if we subtract cosine squared from both sides, well, cosine squared minus cosine squared would cancel, and then minus cosine squared would go to this side, which had a 0 because we moved the 1. So really that came from this identity. We just moved stuff around by subtracting stuff from both sides. So we need to be able to relate that right here in green to the identity that I wrote in yellow. So now I can rewrite my step right here. Instead of sine squared t minus 1 to negative cosine squared t, because of this identity that we used. Okay, so we're not done, because we're trying to verify that statement right here. We're trying to verify that identity. So we're trying to get this side that we chose to work with, because as we discussed in class, it's better to work with a side that has 2 terms instead of a side that has 1 term. So we're trying to make that side to look like this one. Well, we're so close. We just need to do one more thing before we can move on. Let's see. So all I did for this step is that I made that negative float upstairs, which is allowed. Negative 2 over 3 is the same as 2 over negative 3, right? Negative 1/2 is the same as 1 over negative 2. A over b, negative a over b is the same as a over negative b. So all I did is that I made that negative float upstairs, and then I broke that cosine squared t to cosine t times cosine t. Well, how does this help me? That helps me a lot, actually. Sine t over cosine t is tangent t that we're trying to find to make apparent to the person who is grading the paper, which is me in your class most of the time. So we're trying to go all the way to make this step right here look like that one. And then cosine t, if we think about it as 1 over cosine t, well, 1 over cosine is secant, which we're trying to do right here. So the last step is just to say that negative 2 tangent t secant t is the same as that previous step right there. And we have to state that, because I need to take this side all the way through the steps to make it look like the other side. Hope that helps. Thanks.